Welcome to The Jump. I'm Rich Bowers, and I have a familiar face with me here today. Hey, Jamison, how are you doing?
Doing great. How are you, Rich?
I'm doing wonderful. Jamison Ducey works for Cognitia and is the head of the AI practice for our division. And I thought, what is one of the more popular things that are being talked about every single day? And that is Agentic AI. So we have to bring in Jamison to explain to us what that is. Sound like a good plan, Jamison?
That sounds like an excellent plan.
All right, so before we dive into the technicalities of Agentic AI, let's cover some of the few basics for some of our maybe newer listeners to the technical side of AI. When we're saying language model, what is a language model?
So a language model is a type of artificial intelligence that's designed specifically to understand, process, and even generate human language. So it's very much revolving around mostly text-based, I would say. And it basically works by predicting the likelihood of a sequence of words, and from that it can actually generate coherent text based on whatever input that you give it. And it's trained on a bunch of different things, and of course, like with all machine learning, whatever it is trained on, it learns to replicate.
Okay, so let's focus on maybe some of the more popular language models. And typically right now, the general knowledge ones are most popular, the large language models. Is that based off of how much they're trained on, what they're trained on? Is that really where that large aspect comes from?
That's definitely part of it. There's a lot more data. There's a lot of data that goes into normal sized language models. But in large language models, the scope is definitely much bigger, both in terms of the training data that they're given, as well as the number of parameters within the model. You can think of parameters as sort of like neurons. We've got a lot of neurons in our brain. That's what makes us good at language, right? It's pretty much the same thing when it comes to these large language models. Another thing as well in terms of scope is the computational power that goes into it. From one of our recent podcasts on energy, if you guys want to watch that for sure, it takes a lot of energy.
I mean, it's pulling so much information from all these different areas. What areas do they pull from? Is it all internet based, or are there books involved? Where are the data sets typically coming from?
So these data sets, they are in most cases from the internet, because there is a lot of data, a lot of text data on the internet. But there are also, they tend to pull from data sets that are collections of books, basically like corpuses or corpora of books. In most cases these days, though, since we're going for a more natural conversational style with these large language models, it takes a lot of conversational data from the internet. And in a lot of cases, of course, this is a whole nother topic in terms of ethics, they don't necessarily ask for permission. And there are a lot of safeguards that are going into making the internet a safer place in terms of where your data is going when it's being trained, and if you're giving permission for that.
Yeah, so that has also been a hot topic in terms of conversation, and I don't think that's not going to continue to be an issue that comes on up. By the way, before we move into small language models, when we're talking large language models, is that the ChatGPTs, the Geminis of the world as we traditionally think of them?
Yeah, definitely. GPT, Gemini, Claude as well. GPT actually stands for Generative Pre-trained Transformer, and you'll find that if you look up what LLMs actually are, pretty much any of these things that are classified as large language models, they are actually all transformers. So there was never any large language models before 2017, essentially, which was when Google released their Attention is All You Need paper that sort of kicked off this most recent AI hype cycle that we are in now.
That's good to know, especially for our listeners to think about as we move over to small language models. So we have the ChatGPTs as we discussed. Now let's go to small language models. What is the difference, or overall, what is the definition, I guess you could say, of a small language model?
So there isn't necessarily like an agreed upon definition of small language models. They're sort of just in contrast to the more concrete definition of large language models. They tend to use less training data because they tend to be focused on a specific area of expertise in language, and they take a lot less computational space, and they're smaller in terms of parameters as well. So all three of those things that we were talking about in terms of scope, these are just smaller and they are less general, more specific.
Okay, so small language models are typically catered to certain actions or information.
Definitely.
Right? So I think now that we have these definitions, language model, large language model, small language model, and we've talked about what we could think of when we think of some of these terms, let's get to the heart of our chat today, and that is agentic AI. What is this popular phrase that we just keep hearing more and more now? What is agentic AI?
So it's definitely an interesting topic because this isn't the first time that this kind of phenomenon has occurred, but in this current cycle, agentic AI is sort of the realization that, hey, these large language models are really useful and really awesome, but they take a lot of time, money, and energy to train and to deploy. And they are generally knowledgeable, but without any tools or without any autonomy, they don't really do anything outside of what the user asks them to do. And so agentic AI is sort of this realization from the entire industry that, hey, we have the technology now, we have the hardware, we have the models, and we know how they work, we know how to train them. Now we have to integrate them into our systems, and we have to show them how to use our software so that we can automate more. But to do so, we have to give them autonomy. And that's kind of the large ethical question when it comes to agentic AI is how much autonomy do you give something that you're not necessarily constantly watching?
Okay, so this is going to segue into our next couple questions here. The major components of agentic AI are going to be autonomy, adaptability, goal orientation, and proactive, right? They kind of take steps on their own. When you're saying autonomy with AI, agentic AI, is that the same thing as AI agents, by the way?
Yeah, basically. Yeah, it's one thing that I wanted to just mention really quick is that this isn't the first time that this has happened. It really is just more of a phase in the cycle of developing new technology, especially when it comes to AI. Agent-based models, or the agent-based model, is actually from the 80s and 90s. So a previous AI hype cycle actually instilled this idea, and even before then, there were hints of it. So it's definitely more, it's an action-oriented paradigm for sure, as opposed to just a simple language interaction-based paradigm that we've been in. It's a little bit goal-driven, as you said. It's definitely going to be interesting to see how people integrate this.
It's also interesting, and through previous discussions that you and I have had on the jump, that we talked about how the theory was decades ahead of what can actually be put into play. And so now, are we able to get into agentic AI because there is that autonomous reasoning and planning capability? Is that why we're seeing that now, as opposed to in the 80s, 90s, and even early 2000s?
Definitely, I would say so. With the advances that we have in hardware, we're able to do a lot more stuff, and with the advances that we have in theory and in software as well, this has been able to we've been able to generalize a lot of what we know these days. And because of that, corporations, companies, the tech industry in general has become a lot more involved past the 2000s or so with the car automation hype cycle, sort of, I want to say. And into this current hype cycle, we're essentially much more involved in both research and development when it comes to AI. So it's really interesting to see the demand for this kind of technology rise consistently and sort of off-put the normal hype cycle that we tend to see and that we saw in the 20th century when it came to AI, where it was investment into this technology because it holds a lot of promise, and then realization that it can't achieve the things that it was previously promised to achieve, and so less investment. And that's why you get the AI summer and AI winter cycle. It's a little bit different nowadays because people are still very interested and still very invested. There's a lot of large companies that are extremely invested in AI these days and want to keep that going. They want to be able to make a profit off of it. And so as we transition more into having models that are smaller but more familiar with a particular system, we get to see some really interesting things happen, and we get to see that kind of prolonging of this peak of interest.
Got it. And that makes sense, right? There's the use cases, which we'll get to shortly, that actually can be utilized for efficiency increases, generating revenue as well, and making our days a little bit easier. So let's go to the benefits. But before we do, you mentioned autonomous a couple times. What is the benefit to these agents or agentic AI being autonomous as opposed to maybe having to wait for human intervention, though there should be some human intervention, just for the record? Is that a massive benefit, and why the popularity is there now as well, and the potential use cases?
I think so, for sure. I think the added autonomy of having an agent in your system that is able to take all of the data, and without any kind of prompting or anything, it's already ready to go in terms of what it needs to output. So having a human in the loop is, of course, still pretty essential, of course, but that comes into play in different areas. When you have a system that's automated and it's automated well, you don't necessarily have to be constantly monitoring it. If something goes wrong, or if there's some kind of anomaly in the system, then humans come into play to analyze what is going on and to fix things. But when you have a working machine that doesn't need a human, why put a human in there, right?
Yeah, exactly. These agents can take action, they can adapt to the changes well, and then they can learn from those outcomes. What is the perk of that? I mean, I think there's an obvious perk, but obviously there might be even an obvious fear. But what is the obvious perk to being able to adapt from their environment and learn from these outcomes to do better next time?
Right. So that's kind of a big facet of one portion of machine learning that's called reinforcement learning. And being able to put an agent into a system where it has access to all of the data that is being output from the system, as well as the data that is being put into the system, it gives a feedback loop. And the entire point of agents, the agent-based model in general that I mentioned before, is having a particular state, which is the system state, right? And having the model adjust that state to what it would consider or perceive to be the ideal state, or a better form of that state. And from its own actions, from the result of its own actions, it's able to actually learn based off of what it does, which is really, really nice and kind of cool to not have this entire training cycle or phase before you can really even put it into production. I think that's really one of the most interesting parts of machine learning and AI in general for me, is being able to see something learn in real time. So I'm really excited for that.
That's excellent, as long as it isn't focused on making paper clips,
Yes.
as we saw with that issue. And I'll share a link for people to check that one out. So let's kind of walk through an agent's actions and let me know if this is right. A user will interact with its interface. Then a planning and reasoning function takes place. There's some tool calling based on that it requires. It integrates with whatever is needed. There's that reflection loop that we just talked about. And then, this is the important piece, then as it collects that data, there's a policy and governance that comes into play before generating the output. Does that sound about right?
Yeah, that's
For
one way
typical
to think
agents?
about it. Yeah.
Okay, so then that policy and governance, that is normally pretty populated by human intervention? Or is this also something that could be potentially learned by the agent based off of the feedback?
Either or, I would say. I think it is a good place for humans to get into the system when they want to keep it automated by the agent, right? If they want to change certain things, they can edit the constitution or the foundation, but at the same time, the agents can have their own constitution essentially, and not there is no necessity for a human to be right there. We've seen that these agents and models in general can learn from themselves and from each other. But again, the major pitfall with that is if you get a feedback loop that the model is perplexed by and doesn't really know what to do with and can't necessarily learn from it, that's when human intervention comes into play. So it's good to have that kind of endpoint in there to be able to say, okay, let's edit this a little bit and make sure that we're putting in the right data and that the model is actually learning from it.
Okay, perfect. This is a great segue into the difference between these and our general knowledge ones a little bit. So the comparisons and why we might see a shift more towards agentic AI as opposed to large language models.
Definitely.
You talked about going in there and maybe altering the Constitution, like a Bill of Rights, or some other type of larger change than just 10 or 12 different things. A benefit to these smaller, specific or specialized models is that doesn't take as much energy and time, correct, to train that data?
This is true. Yes, for sure. Again, the amount of training data that it takes to make a significant change is definitely going to be smaller. In most cases, because the model itself is smaller, so you kind of retain that same adaptability, but you're still taking out the human aspect of it. So when a system changes, if a system changes, then you don't have to as much get into the gears of things yourself. The model itself is able to adapt to that.
And then my other question to you, you mentioned AI systems. A benefit of these AI agents are that they can interact with other AI agents or AI systems. How is that a benefit over some of these large language models? Is it that it can do it quicker? Is it maybe the large language models don't have the same exact capability? Is there a benefit to that with these smaller models?
Definitely, for sure. I would say that the main advantage is that there's kind of more discussion, I would say, than anything. The advantage of having multiple smaller agents within a system as opposed to one big general system is that each of those agents can be customized to be focusing on a particular thing. And when a system changes or when a system receives new input that seems weird or off or just new in general, these agents are able to actually put in their own 2 cents, and that 2 cents tends to be more specified towards whatever part of the system that they're engaging in. And so you get a little bit more of a dialogue within the system about what is exactly is going on. When you have one large general model, there are certain biases, certain caveats that come with that for sure. And there's definitely not as much discussion going on. There's not as much back and forth, especially if you're trying to use this general model to automate a particular system and you're giving it autonomy, you're not in the loop, then it's not really talking to anybody else besides the system, which isn't responding or reacting to it in the same way that it is reacting to the system.
It's interesting. I know you're also in your day to day, you're working on a variety of different use cases for agentic AI, and I don't want to go into that too much at the moment as more and more of this is coming out and following your work. But when we're thinking about agentic AI, just going forward, where do you see this expanding to? Maybe other pockets of business, of real life use cases that you see that this is going to become more and more prominent in?
Definitely. We keep coming back to this all the time, but when it comes to customer support, having a model that has pretty much all of the knowledge that it needs, a user-facing model like that, like a general model, can cause certain issues, right? There's definitely prompt engineering is getting deeper and deeper in terms of how people can actually hack these models and get knowledge that they're not supposed to have. So having multiple agents in that system where you have one user-facing model that's able to talk to a lot of the other portions of the company, the other portions that may have their own agents, again, there's more discussion there, right? And so certain interfaces that a user would normally have access to with a general model, they don't have access to that anymore, but they still get the information that they need if they are being earnest and they're not trying to hack the model, right? So customer support for sure, healthcare as well. There's so much data in healthcare that it can get really overwhelming for one single person and even one single model, no matter how big it can be. So having interacting systems there is excellent. Supply chain as well, automating inventory management, tracking orders, logistical planning and adjustments in real time, being able to use models for that is going to be excellent as well. Autonomous vehicles, of course, that is still definitely a thing that people are working on. Started in early 2000s, maybe late 90s, and that's still going. I think the more that we get into this agentic AI, the better these autonomous vehicles will behave as well. In terms of like creative collaboration, I personally, I have to mention this at least once every podcast or so, I'm really excited for this kind of stuff in games. Imagine non-player characters that like talk to each other and gossip in a town. Like you do something in the town and you leave for a little bit, you come back, people have talked about what's happened and they've actually put that into the conversation without anybody actually writing that out. And I think that's going to be really fun.
I mean, the first thing I picture is Elder Scrolls. How crazy would that be walking around there?
Right.
So you have a lot. And then while Jamison is sharing these use cases, remember, this is autonomous. It's also going to be adapting. So in the healthcare field, being able to potentially pick up data that humans are not able to and faster, and then instantly respond. That's something that could be extremely exciting. And we're going to see more and more of these coming on out. We see Claude. Sonnet 3.5 actually released a computer use feature, which acts as an AI agent. It takes over your computer screen, looks at data, tabs by screenshots, and then able to input data in different pockets. OpenAI has Operator being released in January, and then I believe Google's working on one that they might release in December. So even though these three are very popular with ChatGPT, different Claude levels, and Google's Gemini, they are also segueing into a little bit more of AI agents for the general public. That's correct, right, Jamison?
For sure, yeah. And I think I actually saw Microsoft Copilot announce that they have a Copilot Actions coming out pretty soon. So yeah, no, it's really interesting to see these large companies that have a full system being able to actually take these agents that they have been user facing so far and just kind of put it into the system to make it more useful without the necessary interaction between the user and the agent.
And you know what? When these ideas were coming in the 80s and 90s, now it is coming week by week, something new.
Yep.
So, Jamison, this is exciting. I know we're going to get back together to do a little bit more agentic AI, maybe a part 2. This is a wonderful setup for anybody looking to understand what it is. Jamison, thank you for your time. For The Jump, I'm Rich Bowers. Take care, everybody.
Bye, guys.
Bye-bye.